Okay, you can. All right. We are going over the assignment that we did on October 20th. You need the light on?
Okay, that's too bright. Turn one light on.
Be quiet, I turned one on. Alright, so this first section asks you to find if numbers are prime or composite. If you used your hundreds chart where you circled the prime numbers and crossed off the composite numbers, there should be no errors on this problem. It should be very, very, very easy. So I'm going to go through it. You're going to have to be quiet or you're going to have to go to Clayton. We're taking the number 3. Ladies, are you paying attention, please?
Be quiet.
The number 3 is a prime number.
Prime number.
Are you checking your paper?
I got prime.
The number 5 is a prime number. The only factors of these two are 1 in themselves. The only way you get to 3 is 1 times 3. The only way you get to 5 is 1 times 5. 9 is a composite number. The factors of 9 are 1, 3, and 9. Those are the factors of 9. Since it has more than just 1 and itself, that makes it a composite number. All right, 14 is composite. It has 1, 2, 7, and 14 as its factors. 1, 2, 7, and 14 as its factors. The number 21 is composite. The factors of 21. Miss Rudnick, you want to be a superstar?
Possibly.
Well, I'm making my YouTube video going over the answers for this for my tutorials. If you want to come over here and star on it.
Shout out.
And then I post them on the Tube of You
The two of you.
on my page.
Is this currently going on the...
Yeah, it's going on.
Excellent.
Yeah.
Excellent.
And then I can show it tomorrow and we're going over it and I just take a nap back at my desk. It's going to be awesome.
No need for me to be a superstar today.
Okay,
I'll
well,
make a guest appearance later.
your voice is on it at least.
That's great. I hate my voice in recording, so this works out well.
All right, well, I'll post it on my page. So.
Can't wait to hear it.
All right. 31. What'd y'all get for 31?
31. Prime.
Prime. 35. What'd you get?
Composite.
Composite. Factors of 35 are 1, 5, 7, 35. 43. Prime. The only factors of 43 are 1 and 43. 51.
Composite.
Composite. Anybody know the factors of 51?
No.
1, 51. If we use our divisibility rules, this number is divisible by 3 if we follow the divisibility rules. Because the divisibility rule for 3 says add the digits together, which would mean make 5 plus 1. And if your sum, which is 6, is a multiple of 3, then your number is divisible by 3. So it's 1, 51, 3, and 17. Because 3 times 17 equals 51. Okay, and 59. Prime. So those are the answers for that page.
Yep.
If you missed it, mark it wrong. Except for you guys, you can just fix it. I'm just saying it's for the people tomorrow that are mean to me.
We can fix it? Yeah. Don't tell me to be quiet.
I'll tell you to be quiet. All right. This next part. If you use your divisibility rules and you can read, it's really not a difficult thing to do.
What are we doing now?
The one that's on the board. You having trouble keeping up? All right, so I'm going to follow the rule for 2. And I'm going to go through all of these and do the rule for 2 first. It's easier to do each rule than it is to go across and have to do each rule 17 times. So my rule for 2 is if the number in the ones place is an even number, or if the number in the ones place ends in a 0, 2, 4, 6, or 8, that makes the number even. So if we look at 48, 48, does it end in an even number? Yes. So 48 is divisible by 2. 64, is 64 an even number?
Yes.
Yes, it is divisible by 2. 125, is it an even number? No, because it doesn't end in a 0, 2, 4, 6, or 8. 156, yes. 330,
Yes.
yes. 27, no. 30,
Yes.
yes. So if I go through them each rule at a time, it makes it much easier to do it. What a lot of you are doing is trying to go 48, is it divisible by 2? Is it divisible by 3? Is it and it makes it much more difficult. So if I just take one rule at a time, then I only have to remember that for that amount of time. The rule for 3. A number is divisible by 3 if the sum of the digits, that means you add all of the digits together, is a multiple of 3. Y'all know multiples. You put a foldable in your journal. So what is the sum of the digits for 48? The sum of the digits. They're the 2 digits, 8 and 4. What's the sum of those digits?
8.
Add them together.
Oh, you told me this earlier.
Yes.
8, 9, 10, 11, 12.
Good. The sum of the digits is 12. We added 4 plus 8, which equals 12. Is 12 a multiple of 3?
Yes.
Yes. What is the sum of the digits in 64? 10. Is 10 a multiple of 3?
Yes.
3, 6, 9, 12. Did I say 10?
No.
No, so it's not a multiple of 3. The sum of the digits in 125. What's the sum of the digits in 125?
Wow.
No, we're adding these. How did you get 20? 1 plus 2 plus 5.
7, 8.
8. Is 8 a multiple of 3?
No.
No. The sum of the digits in 156. 12. Is 12 a multiple of 3?
Yes.
Yes. The sum of the digits in 330 is?
Oh, we're on this side. 330. 6.
6. Is 6 a multiple of 3?
Yes.
Yes. 3, 6, 9, 12. Multiples mean you're counting by that number. So yes. 27. What is the sum of the digits in 27?
7, 8, 9.
9. Is 9 a multiple of 3?
Yes.
Yes. The sum of the digits in 30. You can't add 3 and 0 together?
Oh, this 3.
3. Is 3 a multiple of 3? Yes. The sum of the digits in 93.
12.
12. Is 12 a multiple of 3?
Yeah.
Yes. So these 1, 2, 3, 4, 5. These 6 are divisible by 3. The divisibility rule for 5. If a number ends in a 5 or a 0, it is divisible by 5. If a number ends in a 5 or a 0, it's divisible by 5. Is 48 divisible by 5? No. 64? No. 125?
Yes.
Yes, because it ends in a 5. 156? No. 330?
Yes.
Yes, because it ends in a 0. 27?
No.
No. 30?
Yeah.
Yes. 93? No. Okay. Your divisibility rules for 6 say if the number is even and it's divisible by 3. Another way to say that is the number divisible by both 2 and 3. So if it's divisible by both 2 and 3, it's divisible by 6. So is the number 48 divisible by both 2 and 3?
Yes.
Yes, it's checked up here. Then it's divisible by 6. Is the number 64 divisible by both 2 and 3? No, it's not divisible by 6. Is the number 125 divisible by 2 and 3?
No.
No. 156?
Yeah.
Yes, then that means it's divisible by 6. 330?
Yes.
Yes, it's both 2 and 3. That means it's divisible by 6. The number 27, 2 and 3?
No.
No. The number 30, 2 and 3?
No. Yes.
Yes, it's divisible by both 2 and 3. Are y'all even looking, or are you just yelling out words? The number 93.
Jody Smith and Patty Fitch, please come to Mackey's office. Jody Smith.
They've
Patty
been
Fitch,
fired.
Mackey's office, please.
Okay, 93. Is it divisible by both 2 and 3?
Yes. No.
It's not. There's no check in the 2 column. So it's not divisible by 6. All right. The rule for 9, which I don't think you have in your notes, but the rule for 9 is just like the rule for 3. If you add the digits together and the sum is a number divisible by 9, your answer is divisible by 9. So the sum of the digits in 48, what did we say it was? 4 plus 8? 12. Is 12 a multiple of 9?
No.
No. 9, 18, 27, 36. The sum of the digits in 64. What is the sum of the digits in 64?
10.
10. Is 10 a multiple of 9? No. Sum of the digits in 125.
Oh, that's 8.
8. Is 8 a multiple of 9?
No.
No. Sum of the digits in 156.
Oh, yeah. 6, 7, 12.
12. Is 12 a multiple of 9?
No.
No. Multiple of, or the sum of the digits in 330? 6. Is 6 a multiple of 9?
No.
Sum of the digits in 27?
10.
You just said what she said. 7 plus 2?
It's 9.
9. Is 9 a multiple of 9?
Yeah.
Yes. So this one is divisible by 9.
Okay, hold up.
Hold up, you're just putting one check in.
I got that right.
The sum of the digits in 30?
No.
What is the sum of the digits? 3. Is 3 a multiple of 9? No. The sum of the digits in 93?
No.
12. 12 is not a multiple of 9. Now the rule for 10, which you should all know.
I don't know. 10, 20, 30, 40.
Yes. If it ends in a 0, it is a multiple of 10. It's divisible by 10.
None of those but 30 and
30 and 330. Those are the two that are divisible by 10. So your paper should look like this. I'm sorry I'm having to record on my phone because I have to have the computer on to do this. So if it's hard to see, just use your ears and listen.
Yeah.
Stop. Collaborate and listen. McMurdo's back with a brand new invention. Something grabs a hold of me tightly, flow like a harpoon daily and nightly. Will it ever stop? Yo, I don't know. Turn off the lights and I glow to the extreme. I rock a mic like a vandal, light up the stage and watch it jump like a candle. Dance. All right, on to the next set of problems. Oh, let's go over here. Oh, those are good problems.
Oh, I haven't done that yet. I'll just get it. Okay, I'm ready. Now I have to go to
Peace
work.
out.
Later, man.
All right, so let's look at these three questions.
Let's see. Are we doing this one? Fine.
All right,
This one.
we have three questions. The first one, is 51 divisible by 2?
No.
What's my rule for 2?
Even.
If it's an even number. If the ones place has a 0, 2, 4, 6, or 8 in it, then it's divisible by 2. This one has a 1 in it, so it is not divisible by 2. Is 51 divisible by 3? Our rule is the sum of the digits. So you add the digits together. Add the digits together.
3, 4, 5. 6. Oh.
6. Is 6 a multiple of 3?
Yes.
Yes. The next set. Name a 2-digit odd number that is prime. Name a 2-digit odd number that is composite. Well, I can't put all of them up there, so you'll have to really look on your prime and composite chart in your journal.
We don't have that.
You do. You have the hundreds chart where the prime numbers are circled
No,
and the composite numbers are X'd out.
it's in our locker.
Well, I know, but not right now. I'm just saying when we check this. When we check it. All right, let's move on to the next set of problems. Daytime.
What? We both got the same set. Oh my gosh, I totally have to watch that.
All right, 2 questions. List all the factors of 16. List all the factors of 36.
Oh, I didn't write this one down. I didn't.
The factors of 16. All we do is make a T-chart.
Oh, wait, yes, I did write this one down. Okay.
All we do is make a T-chart. What's up?
What are you doing there? Leave.
Go ahead.
What's on, Jamie?
1 and 16. We always start with 1 in itself.
Oh, this is so crooked.
Does 2 go into 16? Yes, because it's even. 2 times what equals 16?
2 times 1 equals 6.
That's what I said.
8.
2 times 8. 3 times anything equals 16?
No.
4 times anything equals 16?
Yes.
Yes, what?
I don't know, but I know there's something in it.
4 times what equals 16? You're right. 4 times something does equal 16.
Yeah.
4 times what?
4. 4. 4 times 4.
4 times 4.
Oh, man!
So the factors of 16 are 1, 2, 4, 8, 16. Those are the factors of 16.
4, 4, 8.
No. Thank you.
Thank you.
The factors of 36. We're making a T-chart like that. We always start by...
Why do we have to make a T-shirt?
Because that's the way I told you to do it. You always start with 1 and the number,
36.
okay,
Or whatever.
6 times 6.
is 2. Can you multiply anything by 2 to get 36? Is 36 divisible by 2?
No.
Is it an even number? Then it's divisible by 2. 2 times 18
Oh.
equals 36. Is 36 divisible by 3? Add the digits together. 3 plus 6 is
79.
9. Is 9 a multiple of 3?
Yes.
Yes. So 3 times 12 equals 36. Is 4 times anything equal 36?
9.
9. 4 times 9 equals 36. 5 times anything? No, because it's an even number.
6 times 6.
6 times 6.
Man.
Okay? So my factors of 36. 1, 2, later man. 3, 4, 6, 9, 12, 18, 36.
Hey, this is my brother.
Yes. Okay. So this is how you find factors of a number. That is how you find factors of a number. Very easy. It becomes very handy as we move into fractions, which will begin here in a little bit. The next set.
It's a dance. Not my fault. I like this.
The next set says find the greatest common factor, or GCF, of 36 and 40.
Oh,
I'm going to leave this up here, since how I find the greatest common factor is by doing all the factors of each number. So then I do the factor of 40.
That one, you left up on the board.
Oh, I did have it on the board. So the factors of 40, and since it's up there, are 1 and 40, are 2 and 20, are 4 and 10, and 5 and 8.
40.
All of those are the factors for 40.
Wait, it is?
Now, I haven't answered the question yet. Now, I find all the factors they have in common. There is a 1 in the factors of 40, and there is a 1 in the factors of 36. There is a 2 in the factors of 40, and 2 in the factors of 36. There is a 4 in the factors of 40. There is a 4 in the factors of 36. There's not a 5. There's not an 8, a 10, a 20, or a 40. So my 3 factors they have in common are 1, 2, and 4. Greatest means biggest. So what is the biggest factor they have in common? Anybody?
2 and 4.
24.
No, just 4. The biggest one they have in common is 4.
Oh, okay.
So when we're talking greatest common factor, you find all the common factors that they have, and the biggest one they have in common is 4. So that's going to be my answer.
That's simpler.
That is simpler.
Earlier.
All right, so let me move up to the next one.
You know we're not board.
So is it that when we do it in
Let me look at the next one. All right. We do this.
It's not this one. It's not a weed.
Just please stop.
No, it's not a weed.
You're going to have to leave if you can't keep your hands off each other.
That rhymes. We
Okay, good. All right, the same way, greatest common factor. We're going to list all the factors of 81. The factors of 81, we start 1 and 81. 3 and, let's see, it'll go in twice, that's 6, 20, 3 and 17.
3 and 17.
No, 3 and 27. 3 and 27. 4 not, 5 not, 6 not, 7 not, 8 not, 9,
Lover.
and 9.
Lover Carol.
So I really need you to be quiet. Thank you. So all the factors of 81, 1, 3, 9, 27, 81. Factors of 54.
Yeah. So we have 9 times 6.
Okay, so we have 1 times 54.
Oh, yes.
2 times
2 times
27.
what?
Is 27 times 2 equal 54?
Oh.
27 times 2 is 14. 2 and 2 is 4. Plus 1 is 54. All right, so 2 times 27 is 54. 3 times something, because I know 3 goes into it, because 5 plus 4 is 9. So 3, and it's going to be smaller than 27. 3 is going to go into 5 one time, 24, so 16.
Really?
4, does 4 go into it? No. 5 go into it? No. 6 go into it?
Yes.
6 and 9,
Sorry.
and that's all we have. We find the ones they have in common.
Here we go.
They have a 1 in common. They have a 3 in common. They have a 9 in common.
Oh yeah.
They have a 27 in common. What is the biggest number they have in common? 27. Therefore, my greatest common factor is 27.
Oh, that's what the GFC did.
GCF.
Yeah, whatever.
Greatest common factor. Greatest
common
common factor.
I should write that down.
You should.
Yeah, you should.
All right, let's look at these 4.
Squeeze me.
You're a lady, aren't you?
You're really having a difficult time being quiet.
What's she saying? She
Okay, I
she's
just-
not a lady.
You're still talking.
She said that I have a week.
You're still talking. All right, the first 5 multiples of 3. In your journal, you have a foldable that you did on Monday that told you how to find multiples. Quiet or get out.
Go where?
Multiples. 3, 6, 9, 12, 15. Those are the first 5 multiples of 3. Yes, ma'am.
I wasn't here on Monday, I was sick.
Okay, and I gave you the foldable to make.
Yeah, how do I make it?
You follow the instructions that were given to you.
Yeah.
The first 5 multiples of 8. 8,
8.
16, 24,
Oh, I never remember.
32, and 40. That's the first 5 multiples of 8.
It's not a paper.
The next 2, again, is something that you should look at your hundreds chart where you circled the prime and crossed off the composite.
Go kill
And it took my pencil.
Because I'm not able to write them all or guess the 4 that you're going to put on there. Let's see what else
Wait,
we have.
what's the bottom ones? The
Well, that's what I just said. You're going to have to look on your hundreds chart
oh.
because I can't list them all and you only have to list 4 and I'm not going to list all of them. So that's how you find that. And that is all of what we had. So that is the answers. So now those of you that stayed today are going to get 100. Tomorrow you're going to grade it. You're going to mark it wrong if it's wrong. You're going to mark it right if it's right. You're going to turn it into the tray and write minus how many ever you missed.
Yeah.
Questions?
I will be.
Questions, Nevaeh, Tamara, Addie, and whoever you are.
Caitlin.
Oh, Caitlin, that's your name. You haven't been in my class in so long, I've forgotten you. All right. Peace out.
Forgot.
Love y'all. Be blessed.